have the great pleasure of speaking with Chris Bleakley, Associate Professor and Head of the UCD School for Computer Science. And today we will chat about poems that solve puzzles, the history and science of algorithms. Hi, Chris. How are you today?
Hi, Patricia. I'm well. Thank you very much. How are you?
I'm great, thanks, Chris. And it's great to have you on here with us. So first question for you today is, where are you located and how has life been for you over the past few months?
So I'm at home in Dublin at the moment. I'm in the study, you may be seeing the background. So I've been working from home for the last 6 months. I suppose work's been very busy. We've been dealing with lots of COVID-related issues, but it's great now that the term has started and I'm back teaching again, so really enjoying that.
Great. And Chris, you're on here today as you recently published a book entitled Poems That Solve Puzzles, the History and Science of Algorithms. So maybe you could please tell our listeners about this book. And congratulations, by the way.
Oh, thank you. Delighted to get it published. So the idea for the book originally came from my noticing the word algorithms cropping up in newspapers and conversation over the last few years. I guess with media reports about the Facebook algorithm and worries about what's happening with democracy, and even recent conversations about the A-level algorithm and the Leaving Cert algorithm have made the word common currency. But I felt that most people didn't know where the word came from or really what an algorithm was. So I wrote the book with that in mind, to try and answer those questions. What is an algorithm and how did they come to be? So the book traces the history of algorithms from their original invention 4,000 years ago in ancient Babylon, right up to the latest advances in artificial intelligence and cryptocurrencies. So the book tells the story of the people and events that led to their invention, and also explains the algorithm. And it's written for the general reader. It's not written for us specialists in mathematics or computer science.
Super. And I'm sure that our listeners will have a lot of questions about that. So please do remember, if you're listening in, to submit your question via the chat function at the bottom of your screen. So Chris, as you know, in UCD Discovery, we strive to promote interdisciplinary research. And from looking at your research, it seems that interdisciplinarity would play a very strong role. Would that be true?
Yes, absolutely. I mean, in general, in computer science, we've become very interdisciplinary, working with other experts from other fields and other schools to solve problems using computers. For my own work, I'm currently involved with the Consus project, which is a collaboration between Origin Enterprises PLC, which is a large and leading agribusiness. And it's also collaboration between 4 UCD schools. So it's the School of Computer Science, School of Agriculture and Food Science, School of Biology and Environmental Science, and the School of Biosystems and Food Engineering. So it's a large project, and the sort of things we're doing wouldn't be possible if we didn't have the right mix of expertise across the 4 schools and also Origin, working on together in tandem to produce research outcomes.
Wow, that's a very interdisciplinary project. Thanks for telling us about that. So I suppose my last question in the last kind of 30 seconds of our interaction is, what challenges do you see as the future in computer science?
I suppose on the topic of interdisciplinary work, one of our challenges is, we've partnered successfully with a lot of schools and universities across the world to work on topics where computers can be brought to bear. What's changed in the last few years is more and more of the researchers in other areas have actually learned computer science along the way. So now there are programming courses embedded in non-computer science degrees. So something an opportunity for us is to work with these people and to add value, but a threat is that computer scientists become tool makers. We make the tools and everybody else uses them to solve their own problems. So we have to keep our skills up to date and provide added value.
Okay. Yeah, I don't think that's ever going to happen, that computer scientists will be out of a job. Don't worry, Chris. It's your fundamental experts that are needed in interdisciplinary science. And I thoroughly believe that. And we definitely believe that in the Institute for Discovery. So we have a lot of audience questions coming in, Chris, already. So here's one for you straight off the bat. How easy was it to convince Oxford University Press to publish the book?
Yeah, so this is an interesting story. My neighbor and the father of my son's best friend happens to be a published author, Michael Sheridan. So I put together a book proposal and asked him to maybe give me some advice on it. He liked it and he recommended his agent. His agent's father turned out to be an academic, and she and he liked the book and she took it on. So she actually did the hard work of approaching a number of publishers. And I was lucky enough that Oxford decided to take it on. So they go through a review process. So there was 3 independent reviewers reviewed it, as well as the editors in Oxford, and thumbs up, they decided to take it on. That was the way I got in the door.
Super. I love that. In Ireland, it's through our kids' parents that we get our foot in the door. That's phenomenal. Well done, Chris. So loads of questions coming in for you, and I hope I get through them all. But here's one for you. One reviewer of your book on Amazon said its approach to explaining science to the layperson reminded them of Bryson's A Short History of Nearly Everything and Harari's Sapiens. What are your tips for making science accessible to a broader audience, and how important is it that we do that?
Yeah, I noticed that review and I was delighted, because that's exactly what I was trying to do. I read those books and I really liked the style of them. So I suppose I was aiming for that. I suppose I could have taken the approach of just trying to explain the algorithms, but that's a bit dry and textbooky. So I think the context of telling the history makes it more readable, and trying to link things together so that, you foreshadow what's coming next, and then trying to link the theme and trying to explain the context of the algorithm. A lot of the algorithms came out of events like the Cold War and major changes like the Industrial Revolution. So I think understanding how the algorithms came to be for those reasons makes it easier to understand why they're there and the way they work. In terms of trying to achieve that, the secret is lots of work. When I was writing the book, I saw an interview with an author, and they were talking. They said that it took them 14 drafts to write a novel. So I got to 12 drafts. So maybe I was taking a shortcut, but that's my way of getting it to flow, is just lots of drafts.
Yeah. Well, congratulations on it, because that's an amazing company to be in. So here we go. So I'm just trying to bunch the questions so that they because we've so many. How would you define the word algorithm?
So an algorithm is a sequence of well-defined steps that solve an information problem. And algorithms, they're the methods that computers use to solve problems. So once you've figured out a sequence of steps that solve a problem, then those steps can be codified as instructions in a computer, and the computer perform the steps automatically. So when I say an information problem, I'm talking about things like sorting words into order. Could be as simple as that. Could be as complex as trying to play a game of chess. So these are information problems. So it's a method for solving, an algorithm is a method for solving an information problem.
And you're saying using computers, but we've another question here about the oldest algorithm. So obviously this might be before pre-computers, according to your book.
Yeah, so the oldest algorithms were used for solving mathematical problems by the ancient Babylonians 4,000 years ago. And we know that because the clay tablets have been recovered from the ancient ruined cities of Iran and Iraq. And the tablets, on the tablets, they were clay tablets that were inscribed with writing. So the symbols were etched into the clay, wet clay, using a stylus, a reed stylus, and then they were left to dry. So the symbols form a language, and that most of the tablets are concerned with the administration of civil society. They're the records that were kept in the cities for the kings and things like the kings and queens. But some of them contain mathematics, and some of those contain algorithms. So they're laid out very like modern algorithms that step by step, do this, do this, do this, and you'll get the answer. So the first example that I have in the book, it's not the oldest, but the oldest, it's hard to figure out which is the oldest, but it's an example I use in the book. It's a step-by-step algorithm for determining the dimensions of a cistern of water. So it's very like a puzzle from the Leaving Cert. You're given the volume of water, you're given one of the dimensions, you're given the difference between the other two dimensions, and it's this procedure for figuring out the width and length of the cistern. So they think that most of these tablets were actually from students' notebooks. So there's much more advanced algorithms as well have been recorded there, and it looks like they knew Pythagoras' theorem 1,000 years before Pythagoras lived.
Wow.
So
isn't that incredible? Wow. So we have loads of questions, Chris. So we probably, apologies to the audience, we may not get through them all, but the media. So, and we talked a bit about this earlier when we spoke this morning, but the media sometimes, so here's a question, the media sometimes confuse the word logarithm with algorithm. And what can we infer from this? And if people are making such a basic error in terminology, do we have any faith that they understand what exactly an algorithm actually is?
Yeah, I'd be concerned about that. There's a lot of the articles are written, I suppose, people with a journalistic background and maybe not so much a mathematics or computer science background. And there's some things I've seen in articles that are basic misunderstandings. Now, some of the articles are very good and they're very much in depth and the facts are checked, but some of them not so good. So in writing the book, I was hoping that maybe some of those people that are writing those algorithms maybe read the book and brush up a little bit.
I hope so. So algorithms and scoring on social media. So I know we talked a lot about this morning as well, but there's been a couple of questions around that. So maybe you'd comment on that for about 30-40 seconds.
So yeah, Patricia and I were chatting this morning about how Facebook works. So it works, it ranks posts. So any post that anybody makes is ranked for every user, and the ranking is done by a scoring mechanism. So the algorithm looks at a number of features of each post, scores the features, and then multiplies those features scores by a fixed set of weights and adds it up to get a score for whether that post is relevant for that user or not. It then sorts the posts according to the scores for that user. So the ones that scored highest come up highest in your feed. So the factors they looked at are how old the post is, how much effort it took the post to put together. And it could be not necessarily a post, it could be a like or a share or something like that, how much effort it took to do. And then another factor is its relationship to you, your affinity. So that means how close the person that posted it is to you, whether they're a friend, whether you interact with them a lot, whether you seem to have shared interests. So nowadays, machine learning algorithms and hundreds of features are used, and they try to optimize the weights in the scoring system to keep things relevant for the users, keep the users going back.
And are they good at, so it just aligns with another question here. Are they good or bad at predicting?
They're good in a sense. So what Facebook's looking for is try to keep people checking back on Facebook and spending more time on Facebook, because then they get to put in more ads. So they're looking to keep people coming back. That's their metric. If you look at what they're what the recommendations they're producing, they're quite, they tend to give you more of the same. So they look at your history and they give you more posts like that. So over time, it becomes very samey. There's some research going on trying to inject surprise into it.
Okay, and last question in about 15 seconds, Chris, because we're running out of time. What is your favorite algorithm?
My favorite algorithm. Well, in the book, I say that my favorite algorithm is Euclid's algorithm.
Okay, so I don't know what that is, so you're going to have to explain.
Oh, and you have to buy the book.
Okay, so everybody on the call today will have to will order the book. Of course we will, of course. So thank you. Unfortunately, Chris, we are out of time, so sincere apologies to all of you whose questions I didn't get to. I'd just like to say, take this opportunity to say a huge thanks to Chris for the most fascinating discussion today. Thank you so much, Chris.
Thank you very much. Thanks for the invitation, Patricia.
You're very welcome, and thanks everyone for joining in. We run these every Tuesday, so check out our upcoming speakers at zoomforthought.ie. And thanks again, Chris, and thanks so much, everyone. Have a great day and see you all next week. Take care. Bye-bye. Bye.